Hi, I'm Karen Stever with Griffin GGS program. Today I want to bring you a second episode of Cool Science. When one of our webinars has Cool Science on it, it's bringing you basic new scientific findings that impact the horticultural industry. And we'd like to bring those to our Griffin grower partners. If you have any questions about this webinar or anything in general, you're welcome to contact the GGS Pro group at the phone number or the email shown here. The information that I'm going to present today is a very brief and condensed overview of work done by these researchers. Shuyan Zhen in the lab of Mark Van Ursel and Bruce Bugby conducted this research. She's now an independent researcher at Texas A&M University. What these researchers have done is redefine the range of wavelengths that we now know are photosynthetically active radiation. And that is shown here on the right. They've shown us that the far red wavelengths between 700 and 750 do enhance photosynthetic activity of the shorter wavelengths. In fact, there was some evidence of this, now known as the Emerson effect, even at the time the definition of PAR radiation was originally developed, which is around 1976. The experiments leading to the extended definition of PAR were quite broad in their nature. They encompassed everything from short-term photosystem measurements to long-term canopy measurements and full crop cycle measurements. They tested the effect of adding far red to white LEDs and to blue-red LEDs, as well as filtering the far red out of sunlight, either in full sun or in shade. And they conducted experiments on 14 different crops spanning from leafy greens to grains, fruiting vegetables, and including at least one ornamental in there, I believe, as well. The results of all of these experiments were in agreement. They all showed that the far red light enhances net photosynthesis, carbon fixing, and increases the plant biomass. This slide shows just one data set from those experiments, but I wanted to show it because I think it's nice and visual and very compelling that far red light does, in fact, have a role in photosynthesis. On the left here, we see the spectra that were applied in this experiment from a blue-red LED light on the top. And in that same panel, the intensity of the blue-red light was reduced by 50 micromoles, and that 50 micromoles was added back in far red light. So that's our comparison. The bottom panels are the same experiment with a white LED light. We'll notice that the white LED light has a tail beyond 700 nanometers there, so it has a little bit of far red light in it to start with, but we've added to that red light another 50 micromoles of intensity. Then looking at the data at the right, the researchers measured the net photosynthetic effect at the canopy level, and that is shown here. Each of these modulations in that graph are the day and night cycles. This experiment was carried out for 20 days in a growth chamber. In general, you see the amplitude of the curve increasing with time. That's just due to the growth of the plant. But what we're looking at and blown up here in the insets is the difference in that amplitude, the difference in the photosynthetic effect between our red and blue LED in the pink and our addition of far red shown here in the purple. And again, with the addition of the far red to the white light shown in the orange in the bottom panel. Zooming in on the last 2 days here, the dip indicated by the arrow is a drop in the net photosynthesis. That dip occurred when the far red light was turned off for just 30 minutes. This data supports the impact of far red light on photosynthesis. One other thing to note about these graphs is that a greater increase was seen with the addition of the far red light when the base light was the white LED than was seen with the blue-red LED. in the top diagram. So that larger difference was attributed to the tail of far red light that was found in that base light. Together, these experiments, I think, are a pretty clear indication of the activity of far red light. So how does the definition of PAR matter? Well, if you're buying electric lights, it can matter financially to you right up front in the purchase. Far red is one of the most efficient wavelengths to produce. That is that it's a long, low energy wavelength, so it requires less electricity to produce it than green or blue wavelengths. The far red is more efficient. That efficiency carries over to the calculation of efficiency of your light fixtures. The efficiency of your light fixtures affects rebate calculations, and that can affect purchase and production decisions down the line. A second way that it affects is in basic crop research. Ignoring the far red underpredicts the photosynthetic effect. And the photosynthetic parameters that we're underpredicting if we're ignoring the far red, those are used to determine the efficacy of crop inputs in a lot of cases and to develop agronomic programs for those crops. And lastly, it matters to ecology. Understory and shade plants may receive as much as 40 to 80% of their light in the form of far red light, because far red is one of the wavelengths that penetrates well through the canopy of plants. So these plants live on far red, and it will help us develop a better understanding of what those plants need and for the conservation of them in the future. Finally, I want to share some parting thoughts that I've summarized from a recent GLAZE webinar with our primary researchers here. And those thoughts are that many lights currently have far red in the spectrum, but it's not counted as photosynthetic light, and that's creating artifacts in calculations, measurements, and research. The scientific community is on board with changing the definition, and now in papers to help make the transition, they're reporting both standard PAR and extended PAR measurements. So that will help it make the transition, and for the scientific community, it's just a matter of time. We used to use lux or watts per meter. We don't use that much anymore. Manufacturers and the bodies that are setting the standards are not yet on board. So that's not going to drive the industry to innovation in this quite yet. However, that this new PAR definition is being used by the scientific community, that there is good evidence for it, all of these things will incentivize manufacturers to do the engineering, the development, and to add far red capability to their lights, sensors, and photosynthetic equipment. So this will become the norm, but it's going to take a bit of time. And I just wanted to keep you up on the latest updates of cool science. Well, thanks for your time today. I hope that this episode of Cool Science has helped keep you up to speed on what's going on in the research world and how it affects your growing world. If you have any questions or comments or anything that you would like to see presented in one of these webinars, please contact us at the email or the phone number shown here. We'll be happy to take that into consideration. Thanks so much. Have a great day.